Going to Mars has always been a huge goal for a lot of space agencies. But now, NASA has revealed their plans for how to get Martian samples back to Earth. The Mars Sample Return Program is nearing the completion of its conceptual design phase, and it could mark the very first time humanity brings specimens from Mars back to the labs on Earth to be studied. The mission is led by NASA's Jet Propulsion Laboratory, but it also relies heavily on collaboration with NASA's other labs and also the European Space Agency. And it really is an ambitious and complicated plan. It involves multiple missions to Mars launching at the same time, several transfers of the samples between different vehicles, and the first ever launch of a rocket from the Martian surface. And then it also needs a successful return trip to Earth. It's just about bold enough and crazy enough to actually work. It all starts with the Perseverance rover that's already on Mars, roaming around the red planet's Jezero crater. This rover is carrying 38 empty vials, and throughout its mission, it's collecting samples of rock, soil, and Mars's atmosphere in these vials. Since landing in Jezero in February 2021, the rover has already collected 11 scientifically compelling rock samples and 1 atmospheric sample. Once enough of the vials are full, Percy drops them off on the Martian surface, where they'll wait for about a decade to be collected by the next phase of the mission. And this is where it turns into a real relay race. The plan is to launch 2 missions from Earth in the late 2020s. Firstly, in autumn 2027, the Earth Return Orbiter. And secondly, the Sample Retrieval Lander in summer 2028. If all goes well, Martian samples should touch back down on Earth in 2033. That's a long time to wait from now, but hopefully it will be worth it in our quest to understand whether life has ever existed on Mars. Millions of years ago, Mars had a much thicker atmosphere, and water on its surface too, so it's actually a great candidate for life in the distant past. Nowadays, not so much, but who doesn't want to find a fossilized Martian microbe? Let me try to explain the plan for how we will actually get these samples collected and brought back to Earth. Firstly, the Sample Retrieval Lander will touch down on Mars. This contains 2 parts of the mission, one of which is a rocket that will eventually launch the samples off of the surface. The other part has recently been changed. It was going to be a rover that would leave the lander and drive around the surface of Mars, collecting the vials left by Percy and bringing them back to the rocket, where they would be stored and eventually launched. However, due to the recent incredible successes of Ingenuity, the helicopter on Mars that landed with the Perseverance rover, there is a new plan. Instead of a collection rover, the job of collecting these vials could now be given to 2 Ingenuity-style helicopters that can travel around the Martian surface much quicker than a rover, since they aren't worried about the rough terrain. Ingenuity itself has so far completed 29 successful flights on Mars, and its success has paved the way for this cool new upgrade to this mission. Notice that I said these helicopters could collect these vials. But as cool as they're going to be, they'll only be the backup plan. The primary means of transporting the samples to the lander will now be given to Perseverance itself, because its mission is going so well and keeps getting extended. It will now try to bring the vials itself. If it fails or things need to go faster, that's when the helicopters will be deployed. Once the samples arrive at the lander, a sample transfer arm will load them into the rocket that's waiting on the lander. And once they're all secure, we'll perform the first ever launch from another planet. Even this is not the end of the story. This rocket will only take them off the surface of Mars, where they're going to meet with the Earth Return Orbiter, which will be waiting in orbit around Mars. The samples will then be transferred from the Mars Launcher rocket to the Capture, Containment and Return system on the orbiter, and this will then be sent on its way back to Earth, hopefully landing safely in 2033. So that's a complicated plan with about 5 parts to the relay. But recently, JWST has shown us that even the most complicated space missions can work. Having these samples brought back to Earth will let scientists across the globe examine and study the specimens using tools and instruments that are just too big and heavy to send to Mars. And they can also use techniques that are too complicated or take too long to be performed by a rover. They'll also be able to be studied for many generations. We're still studying moon rocks brought back in the 1970s, and this will allow us to test theories and models about the formation of planets, the evolution of the solar system, and the origins of life as these theories are being developed. I'll leave some links in the description in case you want to learn more about the mission, but let me know what you think of this idea in the comments below, and subscribe if you're new. Until next time, stay safe team. I'll see you soon. Bye!